very warm welcome to everyone. What do you know about microfactories? So, a microfactory is said to be something small scale and highly automated. This kind of manufacturing facility would produce small quantities of products. Now, maybe the STEM curricula are kind of theory heavy and too focused on testing, and that might mean students will be disconnected from the tangible realities of engineering and innovation. But what if students could get hands on in the hub of innovation and actually produce something beyond just engineering? Students actually get to practice it. Could this help students better tinker, build, iterate, and prototype? And can microfactories be truly integrated into the education institutions? To explore it all, please help me welcome Professor Suhas Joshi, Director IIT Indore. Professor, it is my sheer pleasure and privilege to welcome you to Maker FM, a special podcast series presented by the Maker Bhavan Foundation.
Thank you. Thank you for inviting me. It's a pleasure. It will be a pleasure talking to you on the topic which I like the most.
So, sir, taking a discussion ahead, sort of just setting the context, we spoke about micro factories, and this entire series is centered around maker spaces. If you were to give me like from some distance, the difference between the two, because one understands that the maker space also helps students create a prototype eventually, and micro factories are perhaps helping students to produce at a small scale. So, what's really the difference between them? How subtle it is?
Uh, I think there are, see, the process of education. We all have. I'll start with something little early. You know, we have different forms of expression in the sense that we have we sing, we dance, we paint, we sculpt. There are many ways of forms of expression of a human. And with those forms of expression, you are trying to express yourself. You are trying to say something. Uh, Gone are the days when we were studying as engineers. At that time, there were no computers. We are not seeing any computer. And the way an engineer would express himself or herself is by making something by hand. We would say, or we draw something, or we show a professor that I have made this. This is something like that. So while I was doing PhD, also we had very little computers. It was never a computer intensive society in the country. And in kind of 2000s, the revolution of the IT revolution, these computers have come in, and students have fallen in love with the computers and related matters of expressing themselves. And slowly, it so happened that we have sort of never kind of innovated the art of expressing by hands. So that has gone back in the academic curriculum. And the expressing yourself in the form of programs, computers, and simulations, and those things have taken a front seat, and expressing by doing by yourself has become a has taken a back seat. Now here we are trying to teach that art form to the engineers, today's engineers, that hey man, you have forgotten the best way of expressing yourself, and now start to learn from the zero. And that is where these microfactories and makerspace, they are actually coming out, and then they are trying to take the students or teach the students the lost art form which was earlier. Now if you take microfactory and makerspace, there are it is like kind of microfactory is a subset of a makerspace. I would say that makerspace has so many things. There are makerspace as programs, makerspace as academic programs, makerspace as credit-based programs. So makerspace is something which is a kind of academic entity, Whereas a microfactory is a sort of a freelance, more open, more, I would say, which is not a very formal architecture, which does not have a formal architecture. Makerspaces have formal architecture. They can run a semester long course. They can run 5 days workshop. They can run weekdays workshop. They can run 6 months workshops. Whatever. You know, the makerspace is program based, whereas microfactory is sort of a freelance. You have an idea and you want to test that idea. How do you test it? It's the microfactory where you go, you try to use those machines and then try to work around it. So that is where both are aiming towards the repositioning the lost form of art of an engineer. Drawing is a language of engineer, what we say, and doing by hands is the way an engineer demonstrates. Those forms have lost, and that is where we are trying to bring them back into the society or bring them back into the culture of engineering. Okay.
That's beautiful, sir. And I kind of love the expression that you just made that Shrija, these are both similar kind of art which perhaps the engineering curriculum has forgotten to actually build with the hand. So what do you think are the kind of tangible roles that these micro factories play in STEM education? And could you see these micro factories actually changing the way students might look at engineering and problem solving?
Yeah. So, that is where we want to make a difference. If you want to make a difference, then, what you have to do is that you have to come with a full force and you have to take a position in the whole system. So far, what happened in engineering education in the country is that there were two courses. One is called as drawing, engineering drawing, and workshop in technology, workshop technology. And they were supposed to be the expression of what is called as the hands-on by the students. But over a period of time, these two, I mean, engineering drawing has really advanced to solid modeling and so many softwares, and it has advanced. But the workshop technology, it has never come out of its own cliche and old conventional machines and ways. So that particular zone is actually defunct. So much so is that the engineers have forgotten that for making something, you have to draw something first. You have to have a drawing and then you can make it. Many cases, many students, they actually learn workshop first and engineering drawing later on. They have no idea that if I have to manufacture something, I have to have a proper drawing of that. And we are running those courses in all the advanced institutes also. The older institutes are not changing. IITs are also not changing. So that space has become a cliche. That space has become a dead space. Every year, I was head of the department in mechanical engineering at IIT Bombay. I would get 300, 400 complaints of how this course is bad and it has nothing to do with the students. And what we were doing? We were repeating the same course again and again, again and again. So that space was defunct in engineering curriculum. And that is where that space has been removed and it is being taken by these microfactories and maker spaces. So you now have completely advanced machines. You have advanced technologies like 3D printing, laser technology, you name it, PCB printing, microcontrollers, sensors, you name the thing and it is there in these systems, which was need of the hour, which has been a need of the hour, that you in engineering has not remained a singular profession. You want to work in mechanical engineering, you must have a knowledge of computers, you must have a knowledge of electronics, you must have knowledge of sensors. If you want to work in electrical, you must have knowledge of mechanical systems and stressings and strains. The real life problem solving is never a singular branch. It's a job of singular branch. It's always a large number of branches or multidisciplinary or interdisciplinary knowledge is required. So maker spaces help, maker spaces or microfactories help the students to learn all these aspects together. A guy or a girl who is using makerspace or microfactory has to learn mechanical processes of cutting, milling, drilling, grinding. They have to learn 3D printing, they have to learn laser operation, they have to learn electronics, they have to know programming, they have to know sensors, integrating how to mechanical system, integrate mechanical system with electronic sensors, how to program the electronic sensors, how to draw a PCB. Now it is a wholesome exercise. Any system development is a interdisciplinary and wholesome exercise which draws a lot of learnings for the student. And it is essential that you cannot be a one kind of engineer and develop a big system. One of the most important hallmarks of a system is that the integration of several disciplines. You make a sensor, you require mechanical device, you require electrical device, you require electronics, you require so many things to make a system. A system is an integration of multiple streams of engineering. And that is the biggest learning of the maker spaces or the tinkering labs or what we call it as the microfactories, that they teach the integration. And let me tell you that you don't have to, these things don't come by teaching. You teach them electrical separately, programming separately, mechanical separately, and then say that, okay, now you decide when you want to integrate. No, these have to learn on the job, in the shop floor, in the institute itself. With these microfactories and maker spaces, we have designed a program in which all these qualities, all these interdisciplinary knowledge is actually learned by the student in the first year itself. So breaking the boundaries between the branches, between the disciplines of engineering is the job done by these microfactories and the maker spaces. They break the boundaries. You take admission in civil engineering, but you have to learn electronics, PCB printing, laser technology, everything you have to learn. And that is done right in the first year of makerspace. And that is where you break the boundaries, you widen the students' horizons, thinking horizons, and now they find that everything you learn electrical subject, they say, oh, it is useful here. You learn mechanical, it is useful here. You learn computer, it is useful here. They make all the topics they learn later on, they become relevant to them. So the learning becomes relevant if they break the boundaries and move across the boundaries seamlessly. So naturally, they will innovate better. They will have the understanding of interdependency, interfacing, integration, and assimilation. So they can learn far better engineering because of these microfactories. Learnings from the microfactory, I would say.
Thank you so much, sir. So I think this entire attitudes about breaking the boundaries is kind of embedded in the students from the year one itself. Like you mentioned, it is about having a multidisciplinary approach towards learning in life. Even if you're a civil engineering student, you have to cross-pollinate your ideas with students of other streams. So there has to be cross-pollination across different streams. You can't necessarily relegate yourself to a particular silo. I get that, sir, and it's a significant departure from, say, a rote learning or a theory-based learning method. Suppose you play this out. I'm Shrija, I go to IIT Indore, and I spend some time in a micro factory, and I have to tell my parents or tell myself, and I have to prepare myself for the future. What really are some tangible and meaningful outcomes in terms of what I could learn and imbibe in terms of an ideal time frame for working in a micro factory, according to you, keeping in mind what would actually prepare me for the world outside?
You see, the job of a professor is to give a problem to the students, but at the same time ensure that he or she succeeds. The joy of success has to be achieved by the student. Then it can be a whatever mark, low mark students who is having low marks or high marks or nothing. The joy of success is same for everybody. You can be a meritorious student or you can be a ordinary student. The joy of success is same. So, how do you design a program which will ensure that it will give you the joy of success? So, there are small ingredients to the makerspace course. Those small ingredients will create a sense of achievement in the students. And when they all come together, a group of 5 students come together, and when they present their device and device starts working, you will not believe the sense of joy they have. Each one of them has contributed something into the system. And when the device starts running, it is all integrated, multidisciplinary device, and it starts running. The joy of success is same for all of them. And that is where the most important part. That I learned a trade of cutting, I learned a trade of shaping the material, and I just get out of the workshop. That is not the way. Students work over time in maker spaces and microfactories. Now our workshop people are telling me that, sir, पहले तो student आते नहीं थे, अभी जाते नहीं है student lab से. They work overnight. So yet another thing which we do is that to get them early joy of success, on the first day or a 0th assignment is to stitch their own apron. Okay, you take body measurements and you should stitch your own apron with the stitching machines. Believe me, though we all go to tailor and we shout at the tailors, that आपने ऐसा नहीं किया, वैसा नहीं किया, ये नहीं, वो नहीं. But it's a very difficult for a 12th standard student to complete that exercise. The first time we gave that exercise, 200 students were working for almost like a month to complete that. We also did not know how to impart that skill into the students and how to actually do it. But it's a very big challenge. But in the first week, now they make it in the first week. So they have the first success that you make your own apron, you wear it, and you come to the makerspace lab. It's so much of pride because I said, no, that you should wear your success on you. It's like that. They wear their success. However bad it is, it must have been stitched badly or whatever. But, they are proud of it because they have stitched by their own hands. So that is the job of a microfactory or a job of a professor, that every student has a right to succeed. And it is the job of a professor to ensure that they get that joy. Their job, their output is not correct, output is not good, then nothing will come out. Then you will say that, oh, I have given project and nothing has happened. No, you are given project, but you are not ensured that they will succeed. What is required for success? That has to be done. So that is where I am sure you come to IIT Indore Makerspace, you will definitely like it. You will not leave it.
While I'm listening to you, I'm almost conjuring up the ideas of actually visiting your micro factory. It's actually very, very fascinating. So, let us spend some time on design thinking. How did you get into design thinking, and what really is the process of successful design thinking? I will test, I will iterate, and maybe again go back to the drawing board to iterate. So there has to be an outline in thinking. So when a student works in microfactory, how do they better understand this design thinking approach and work on it again and again till the time they iterate and retest to the end user and keep refining their solutions?
So, what is design thinking? I will explain that first. Fundamentally, design thinking is based on a basic premise. The basic premise is empathy. Empathy means what? You have to put yourself in the shoes or in the place of a user and try to understand what are his or her needs. If you can do that, the better you can do that, the better you can design a product. So empathy is the fundamental aspect of a design. You should be able to visualize what are the needs, what are the told needs and what are the untold needs of the stakeholder or the user. And for that purpose, you have to study. You just cannot design a product without understanding the needs, and then design. So the design thinking is, what is that thinking? What are we thinking? We are thinking of the needs of the stakeholder. And the better you think about the needs of the stakeholders, then you can design a better product. You can prioritize those needs. You know that 100% needs cannot be taken care of. But if you put yourself in the shoes of the stakeholder, you will be able to prioritize those needs. So one is identifying needs, the second is prioritizing the needs. That if I prioritize, if I take care of 4 needs or 5 needs, the rest of the things will be automatically taken care of, or I don't have to waste my time on that. If your product is oriented towards designing, taking care of minor needs and forgetting about the major needs, then the product is not going to work. So design thinking is this, that how do I understand the needs? How do I prioritize the needs? And now comes the situation of ideating. What is that? How do I ideate it? How do I design it, whole system, so that major needs of the user are taken care of? And then comes, even then also, repetition and iterations and all those things come into picture. But that design thinking is very important. You have to have, this is the, what we can say, the soul of entire process of learning. Sorry. The first year when they come and learn, we don't tell them much about this design thinking. The first is to acquire some ideas and skills and, soil your hands in all these things. But second time you come to Makerspace in your second year or third year and take up a project, that time this thinking is important. Third year, when you come back with a capstone project to the Makerspace, oh, then in that case, you have to really, really dig hard, deep inside the requirements of the stakeholders. And when you come to final year project, if you want to really make a product out of it, then lot of design thinking has to be done. It's like a child's play, that we don't tell the child that, oh, I'm going to teach you singing or I'm going to teach you playing an instrument. We just give one singing, one instrument, the sports, everything we give. And then experiment the child with all that. That is what is done in the first year. But as they go further, they need more and more thinking, more and more ideations, assimilations, integrations, and all those skills. And that is where the design thinking is very important. And it has to be learned over a period of time. You need to visit makerspace or microfactories for different purposes during your 4 years time. So we have designed a curriculum so that the student is forced to come. First time it is compulsory, but second, third, and fourth time it is optional. It is not necessary. But if they like it, they will again come second time. They will come again third time, and so on and so on. So it is like this. The design thinking is the basis, but it has to be inculcated slowly among the students.
So, what about dealing with failure? Sometimes all of us have this habit of falling in love with what we create or what we produce. And here we're talking about students who are very agile, nimble, and there's sort of endurance that they have and passion that they have to whatever they're producing. So, how do you explain to a student on accepting the feeling of failure? How do you deal with the feeling of failure on what they have produced with so much of passion and love, perhaps for the first time? What are the conversations in that regard?
So I'll tell you the fundamental. Okay, I'll always start with the fundamental. That fundamental of an engineer, fundamental virtue of an engineer is to work under constraints. Okay, an engineer has to find out the boundary conditions, what we call it as boundary conditions. a solution to a problem cannot be an open solution. Solution to a problem has to be under certain boundary conditions, under certain constraints. An engineer is trained for that. An engineer has to work. Any problem they take, they will first ask what are the boundary conditions under which I have to solve this problem. Yes. Time is the most important boundary conditions. Resources is the most important boundary conditions. When you have time and resources constrained, you tend to give poor solutions. And that is not acceptable. Many times people say that, oh, yeah, this is required for by the poor people. Give them low cost solution. No, that is not correct. You have to give most advanced solution, but at the most least, or I would say most affordable cost. Not least, but most affordable cost. Most advanced solution at most affordable cost, if you are able to give, then you are definitely going to succeed. Any one of these is missing, you are giving low cost solutions, least low technology solution, which is low cost, nobody will accept it. You are bound to fail on the day number one itself. You have to see that most advanced solution and at the affordable cost, and that requires innovation, that requires design thinking, that requires out of the box thinking. Then only the new solutions will come. So the fact that you master the art of design thinking and design the solutions, ideate the solutions with the modern technology, with the aim of giving modern technological solutions to the needy person, but at the affordable cost. So cost, affordable cost, high technology, and time. These are the most important constraints. So engineers have to learn. They learn, but many times they forget about one of those constraints. Sometimes they forget about time, sometimes they forget about cost, and sometimes they forget about the technology. And if you forget about these, then your solution will not work. It will go somewhere here and there. It will not be a right solution. So if you are mindful of that, of these constraints right at the beginning, then you probably can develop a solution which can be further improved in stage 2 and stage 3 and something like that. So design and this process of makerspace is not a one-time process. It has to be stepped process, right from a child's play to more formal, and then finally you solve actual real life problem. Actually, you make a device and which will solve somebody's problem. So it's an iterative process for the learning of a student. But when they go out, probably they will all the stages will be combined, and they will be able to do far better when they go out of the institute, and they will be able to deliver much better solutions because of these experiences. Failures are always there in academic environment. We don't professors give a little bit less marks, but it doesn't matter. I mean, beyond that, professors won't harm your entire career because you have failed something. It's a different in academia. Academia, it is notional failures. The failures can be overcome, but outside it cannot be. So for that purpose, they have to overcome these failures inside, design them well, and all those processes which I will say.
So we spoke about the three key ingredients on what really is required in making a successful prototype. We spent some time on design thinking and such a meaningful conversation thus far. But I have to ask you that this concept of microfactory, if it has to achieve its full scale and impact, it can't necessarily only be relegated to the IITs, which anyways get the best of the best, the cream students. The impact has to scale up, and for that we have to go beyond the IITs and perhaps to tier 2, tier 3 engineering colleges. So what do you think are the logistical challenges in terms of scaling this up beyond the IITs?
You see, I will come to challenges, but I will explain you how the model operates or should operate rather in ideal conditions. So microfactories and makerspaces are made for the students and operated by the students. It is that the senior students will teach the undergrad junior students, and as they go further and further and further, the senior students will take a backseat and take a managerial role or overall controlling of the whole thing, and then they get out of the system, and their space is taken by the junior students as they graduate. If it is operated by the students and for the students, then it is feasible to operate anywhere. You don't require a large amount of manpower for that purpose, because the senior students will train the junior students, and then you go further and you go further and you go further. Of course, for the maintenance of the equipment and training of the first time, you require trainers and maintenance of the whole system. I think for training and maintaining, we can have manpower as much required as you want, because that depends on the scale of the microfactory or scale of the makerspace to how many number of students you are engaging in that. So basically, it is the operation. If you design a system in such a way that the students will take care of the uh, peer learning and peer teaching in the whole process, then professors don't have to come in. Professors will come in only for the evaluation of the uh, your products or your processes and all that. Professors will design the program, different programs of training, short duration, long duration, what are the ingredients required, what it should be, which machines and which operations should be taken up this year, what should be done next year. Professors are, surrounding, they are behind, they are surrounding the whole thing. They will not operate. The operation is done by students. Maintenance and training is done by the experts, which are expert in this. And as the scale of the microfactory grows, you require a good control of manager who will, maintain all the machines, new machines, purchases and processes, and expansion and all those things. So basically, you require a managerial team and a good team of students. A culture makerspace or a microfactory is a culture. It is not a. It is not a. Somebody has to be teaching somebody, and you must learn like this, and go ahead. No, that is not. It is a culture, and the culture has to be inculcated among the children, among the students. We have established one microfactory in College of Engineering in Ujjain, which is about 80 kilometers from there. Here, so we brought 20 students here, trained them for 1 week here, and then we sent them back. We called their professors, we trained them here, then sent them back. And we have one technical person who is positioned there. And slowly the junior students are learning and they are imparting knowledge to the younger ones. Let me tell you, the peer learning is the best way of learning. It's almost like a self-learning, and there is nothing other than self-learning in this world. If you can learn yourself from your peers, and the job is done. So from the moral perspective, it can be expanded, but the difficulty is bringing that culture, inculcating that culture among the students, among the professors is required. We are now saying that uh, we want to recruit specialized professors in this. Those who are interested in solving the industrial or societal problems by means of using microfactories and making devices. So we can have a generation of at least a group of professors who are dedicated, maybe 5 professors, 4 or 5 professors who are dedicated, a group of maintenance people, and host of the students who are actually the implementers of the vision of the professors or vision of the microfactories. And that is where the culture. So it can be done anyway. Really speaking, it doesn't require a lot of resources apart from the machines and equipment. I mean, the capital equipment, that's different. But rest of the things are manageable. Scaling up is also possible. That is not a very big deal. As I said, it's a culture which you have to, or an institution has to take a pride in it and say that, yeah, I want to establish microfactory. I want to establish this kind of a culture in my institute. It's a little long-term process, but it is definitely scalable to any place, anywhere in the country.
What do you think is the level of acceptability of microfactories from other institutions? Is there a certain kind of backlash, or do you think there is absolute readiness when it comes to accepting and integrating microfactories or makerspaces as a core part of the curriculum?
So I'll take one example of here where we are establishing microfactory. In our institute is very new, so acceptability was not a problem. But if you go to IIT Bombay, it took me 4 years of work to first introduce that course in actual curriculum of the institute. So it is very hard in old institutes. But newer institutes, it's very simple. It's not that difficult because that mindset has not crept in. But when you go to other engineering institutions in the country, they do not know the fundamentals. They do not know what it will happen. The students' enthusiasm has no bounds. I can tell you that. And students are interested in day and night, and they are ready to do anything. It is the professors who need to be little bit taught and who need to be sensitized about this. And I had a meeting with the professors, including the senior professors there, and they told that right now you don't do much things. Whatever your lab experiments are there, give the students opportunity to perform only 2 experiments in makerspace. It can be mechanical, it can be electrical, it can be computer science, it can be whatever. Whatever your lab courses are there, among those lab courses, you just allow them to work 2 courses in your in makerspace. And our team of professors worked with them, and they identified, that okay, so now it came to 2 experiments per second year, third year students they will do, and our microfactory, our makerspace lab is now 100% utilized because there are large number of students. They are only performing 2 experiments, but it is completely utilized. So, so spirit has to be imbibed and cultivated. Once it is cultivated, things will take automatically shape. One another thing which is very important, which is probably a sort of a challenge, is the consumables resources, because consumables required for making those devices and turning your dreams into reality require some consumables. I have surveyed several microfactories abroad, and they don't, excessively punish the students for consumables. They actually facilitate the consumables. They bring industries, they bring some of the philanthropists and say that, okay, you give us a lump sum, few crores of rupees. In the interest of, out of the interest of that, those few crores of rupees, we will keep giving the consumables at a very affordable cost to the students, because that becomes a very important hindrance to the creativity. You have a concept and you don't provide them appropriate consumables, then what are we trying to do? So of course somebody has to pay, but there are a lot of people who are like Hemant and Maker Born Foundation and a group of people who understand this, that the students cannot pay from his or her pocket. So they charge very small amount for the student to become either a member or become for the consumables. Or sometimes we give make a kit which probably costs about 2,000 rupees. So we say that okay, the student should pay 500 rupees for this 2,000 rupees kit, so that there is some accountability and all that. And whatever, if somebody is not able to pay even 500 rupees, we don't, we don't stop him or her for using it. But it's a creating a sense of accountability among the students is also required. So that way, this consumable part has to be a little bit, taken care of. Providing resources to the students has been taken care of. So I have given certain models to the institute. So far, in 2 years, I have not got any complaints. I said, they are not, as long as students are not complaining and professors are not complaining. I said, some model is working. I don't know how it works, but they work out something. They get out and get money from somewhere and they work. As long as it is self-moving, I have no problem. I don't, my intervention is not required. But that's the way, that's one hurdle which one has to be sensitive about the maker spaces.
Thanks for this incredible conversation, sir. And like you mentioned, it is actually about the mindset shift. What we are talking about at the end of the day is a core mindset shift. Resources will happen, costing, affordability. Those conversations are later conversations. But as long as we have this mindset shift, everything will fall into order. But the initial idea has to be the mindset on how to change the engineering education in the country. Thank you so much, sir, for sharing your ideas and for such an incredible conversation. I have to do some rapid fire with you now. If you were to mention one overhyped technology according to you, what would that be?
I think 3D printing is something which is coming up very rapidly. It has been getting transformed also in number of ways, so that at the end, whatever limitations 3D printing has, people are doing a lot of research to such that you should get the closest product, closest to the final product, as close as possible to the final product. So I think 3D printing is one technology probably which is going to be far more widely used and innovated in the coming years.
So while we were talking, you spoke about the fact that Srija design thinking is nothing but this empathy which is central to it. So if you were to tell me one conversation with a student or one incident which left a lasting impression on you, what would that be?
So, I had given some first time probably that kind of a project to a student that there is a NGO in some rural area in Maharashtra, Latur district. This person who runs the NGO is a very poor man. He's not a very wealthy person. He's a poor man. But he felt a big need of helping somebody. He found that most of the beggars out of around the temples or sitting across the temples are actually blind. Many of them are blind. They are brought by the faculty the family members, and they are put there and they beg. At the end of the day, their earnings are taken away by these family members, and they are given some food in lieu of that. If they don't get enough money, they are treated very bad. So you can see, imagine that this person who is a very poor man, he felt empathy for them, saying that they should be living like humans. So he caught hold of several of such blind people, totally blind people, and brought them to his home. And then he gave them a work of weaving mats. So in the city of Latur, there is a place where the women can give their old saris. So if you give 6 saris and pay some 60 to 100 rupees, you will get in another 10 days time one mat, which will be delivered to your home. Now these people take that these saris, and they cut the saris into ribbons along the length. And then they join at the end these lengths, so they make a long thread of the cut ribbons of the saris. And then in the threads, like threads are there vertical, these ribbons are woven, like alternately, in a handloom, these ribbons are woven. It takes at least 8 to 12 hours for one blind man to weave one mat continuously if he sits then, but it is not possible to continuously. About 12 hours it takes. About 4 by 6 mat of 4 by 6. Then it is woven, and then it is sent back to the given to the customer. About 50, 60 rupees or 100 rupees they get. So, it is the design thinking, the empathy that he has. At least I interacted with him some 25, not 20, maybe 10 years ago. At that time, he had 25 families. He built some huts for all of them in his village, and they all 25 families are staying there. There they cook. Both husband and wife, he got some, they married, and he whatever he has helped. But both husband and wife, they work. They are completely blind. They are completely denounced by their families, but they live a very respectable life. And that is where the empathy comes into picture. They had some cutting issues, so I had gone there because the blind people were not able to cut the ribbons in a very they would not be able to cut it properly, and that was so they asked me that do you have any machine. So I gave one of my students who happened to be from Rajasthan, and he happened to be a son of a family member of a wooden carpenters. And this guy has designed a machine made of wood only. All plywood and wood and all that. He made a machine which is made of plywood. So, what I'm trying to say is empathy is very important in design thinking.
You're the director at IIT Indore, you've had such an illustrious career. So, what keeps you going? If you were to talk about one high point in your career, what would that really be?
I think I told you that my way of thinking is that people should enjoy their work. It can be study, it can be project, it can be whatever. I want to see them successful. They have a right, as I said earlier also, they have a right to taste that joy of success. However big success it is, however small success it is, but they have a right to taste that success. So you have to, work around the boy or a girl so that they are successful, and they get that confidence because of the success, and that is what is the basic of all these things.
Thank you so much, sir. So maybe the idea of micro factories in STEM education could go beyond some theoretical concept. Maybe a micro factory could just reimagine the entire learning experience. Could a micro factory play a key role in helping students to not just build things but also think critically, creatively solve problems, and expect the unexpected? Can we see micro factories be more than just an add-on to the curriculum and actually be a core part of it? Can we see the future of learning about doing as much as learning? It was incredible to have you, Professor Joshi, to answer some of these questions and unravel your experiences in such a forthcoming manner.
Thank you very much.
To our listeners and watchers of Makers FM, till the time we see you next, goodbye and good luck. And thank you so much for tuning in.